All right, so the next thing we're looking at is net. This says a net is the two-dimensional figure that results when the surface of a solid shape is laid out flat, showing each face of the solid. So net is the two-dimensional figure that results when the surface of a solid shape is laid out flat, showing each face of the solid. So in other words, if I cut up this thing and lay it out flat, if I cut up my cuboid and lay it out flat, this is what it becomes. But this is important, guys. The net of all solid shape with a uniform cross-section, the net of the sides, so we're not talking about the top and the bottom, the net of the sides of all solids with a uniform cross-section may be represented as a rectangle. The net of the sides of all solids with a uniform cross-section may be represented as a rectangle. Guys, now, so here it is that we have this cuboid. And when I open it out, the cuboid becomes this, which is the net, All right, so this is the net of the cuboid. Now, please note, there has to be a connection between the solid and the net. And this is the connection. The height of the solid becomes the length of one side of the rectangle. So this middle piece here opens out and become a rectangle. The middle piece opens out and become a rectangle. All right, the middle piece opens out and become a rectangle. So what are the connections between the solid and the rectangle? Well, for starters, the height of the solid becomes one of the side of the rectangle, and the perimeter of the solid becomes the length of the other side. So you can see that this side is a perimeter. Length plus width plus width. The perimeter of the solid becomes the length of one side of the rectangle. So the perimeter of the uniform cross-section of the solid is the length of one side of the rectangle, and the height of the solid is the length of the other side. If this was face-to-face, I would be showing you this example using a sheet of full leaf, which I probably will try on camera in a couple of minutes. All right, let me just go through the introduction. So we're looking at net shape. Turning the page. All right, so this is a cylinder, which is also a solid shape with a uniform cross-section. You open out the cylinder. Now, the distance around the edge up here, that's a circumference. It becomes this length. So the circumference becomes the length of the rectangle, and the height of the solid becomes the width of the rectangle. All right, and of course, you have the two circles at the top, one at the top and one at the bottom. So the net, so this is the net of a cylinder, which is a solid shape with a uniform cross-section. Guys, let's talk about the net of a cone. Now, oh, we don't reach the cone yet. Let's go back up. This says the net of the curved surface of a cone, so it is the cone we're dealing with. The net of the curved surface of a cone is a sector. So imagine that this was a party hat, or yeah, let's say a party hat for the time being, and I cut it open from the bottom up to the tip and open it out. Your party hat would open out and become a sector. So the net of the curved surface of a cone is a sector. The circumference of the base of the cone is the length of the arc of the sector. So the circumference of the base here becomes this length here. The circumference of the base of the cone becomes the length of the what? Of the sector. Stay with me. And the slant length of the cone becomes the radius of the sector. So the slant length of the cone becomes the radius of the sector. So the L for the cone is the L here. It's the L that is the radius of the what? Sector. And the circumference of the cone becomes the length of the arc of the sector. All right. So we're looking at net shape. This is what happens when you sort of like open out your shape and lay it flat on the ground, or and show it flat out. The shape that you get is called the net. All right, let's turn the page and see what's coming next. So here is example 8, which is a question on the net. All right, let's have a look at this. All right, so example 8 says that at a factory, a rectangular piece of sheet metal, 32 centimeters long by 50 centimeters, this is rectangle A, B, C, D below, is made into a cylindrical container by first joining the two sides of length 50 centimeter. So they join this side with this side, and when they do that, they end up with a cylinder. So this is like A and B joining together. A and B joining together, they do that. And down by the bottom, it would be D and C joined together. So you join the side AD with the side BC, and it forms a cylinder. What we're asked to do next is we're asked to calculate the radius in centimeter of the base of the cylinder that is formed. So we need to find this radius here. Now, in order to do this, you have to first realize that AB, which is the length of the rectangle, became the circumference of the cylinder. AB, which is the length of the rectangle, became the circumference of the cylinder. And so the circumference of the cylinder, which is 2 pi r, is equal to 132 centimeters. So this is something that we know how to do. Let's put in what we know. This is 2 times 22 over 7. We don't know what r is, but we know that 2 pi r is equal to 132, because the length AB became the circumference of the circle. So this is 44r over 7 is equal to 132. We did this, if not yesterday, the day before. Guys, if I have one fraction is equal to one fraction, I want to get rid of the fractions, I would cross multiply. So 1 times 44r is 44r is equal to 7 times 132. If I divide both sides by 44, I would get r is equal to 21, because this goes into this 3 times. 3 times 7 is 21 centimeters. So the radius of the cylinder that is formed when AD and BC are joined together, the radius of that cylinder is 21 centimeters. Next, we're asked to calculate the area of the base of the container. So this is the base of the container where the radius is 21. So the area would be equal to pi r square, which is 22 over 7 times 21 times 21. 7 into 21 goes 3 times. So this is 22 times 3 times 21. And the area of the base is 1,386, and this is centimeters square. Next, we're asked to calculate the capacity of the container. Because remember, now this container is formed when a rectangle joins and become a cylinder. When you join two ends of a rectangle and it became a cylinder. The capacity, which is simply another name for volume, is equal to A times H. The area we just calculate is 1,386 times the height of the container, which is 50. Let me show you why 50. Notice, the height, you form the cylinder by joining A to B and D to C. BC, which is AD, is 50. So the height of the cylinder is the same thing. It's also 50. So the volume or capacity would be 1,386 times 50. The capacity of the container is 69,300 centimeters cube. Then this says, draw a sketch diagram of the cylinder and include the dimensions of the height and the radius of the base. All right, so let's see if we can draw, well, it's very easy for me. I just press copy, I think. Copy. And that didn't work. I think it's duplicate. I need to press duplicate. Very easy for me to draw my cylinder because I have the power of technology. Wouldn't be so easy for you to do? All right, I think this looks like it needs to move over a little. All right, so I drew my cylinder. So this cylinder is formed when I join A to B. So we have A here, B here, and D here, and C here. A and B, D and C, you join them together. So the radius is 21. The radius is 21 centimeters and the height is 50 centimeters. So we're asked to draw a sketch. Then now here's what we're told. We're told that what? We're to calculate to one decimal place the depth of liquid in the container when it contains 45 liters of liquid. So somebody pour in some liquid. Duplicate. All right, they pour in some liquid in it. I wish I could change the color as well, just for it to be different. So somebody pour in 45 liters of liquid. And this would be the height of the liquid in the container. And this is what we need to find. It says calculate to one decimal place the depth of liquid in the container when it contains 45 liters of liquid. So looking at the liquid now, the volume is equal to A times H, and that is 45,000 centimeters cube. We're just looking at the liquid. All right, the liquid takes the shape of the container. The container is a cylinder, so the liquid in the cylinder is also a cylinder. Now, the height of the liquid we don't know, but we know that the volume of the liquid is 45 liters, which is 45,000 centimeters cube. We know that the area of the liquid is the same as the area of the container. So this is 1,386 times the height is equal to 45,000. If I divide both sides by 1,386, I'm going to get the height of the liquid to be so we have 45,000 divide by 1,386, and the answer is 32.5, and this is centimeters. The height of the liquid in the container when 45 liters of liquid remains, the height is 32.5 centimeters. So example 9 says, sector A or B below, not drawn to scale, is a representation of the net of a cone. Show by calculation that the circumference of the base of the cone is 88 centimeters. All right. So what you needed to remember is that the circumference, the length of the arc from A going all the way around to B, the length of that arc is actually what becomes, the length of that arc is actually what becomes the circumference of the base of the cone. So the cone is formed when OA and OB are joined together. When you join OA and OB, the cone is formed. So I have my cone. I have my oval. Let's draw the oval. All right, so largely, let us say that this is our cone. Very easy for me to draw because I have, as I said, I have the technology. Which allows me to turn every stroke into a straight line. All right, so it look as if, yeah, my artist, not really. All right, and so this is the radius of my cone. All right, so here's what we're asked to do now. So remember, so this now is formed, the base is formed when I connect A and B together. A and B together. All right, sorry. Let's put it here. I connect A and B together, and this is O. And when I join this A and B together, it forms our sector. So this is OAOB, so this is 21 centimeters, 21 centimeters. So what we're asked to do now is to show that the circumference of the base of the cone, remember the circumference, it is L that became the circumference. So L, which is equal to the circumference of the base of the cone, is equal to theta over 360 times pi r squared. So it is 240 over 360 times pi, which is 22 over 7, times radius, which is 21. So we're looking at the sector times 21. All right. So it's times 21. So it is the length of the arc that becomes the sector of the cone, that becomes the circumference of the base of the cone. So let's calculate the multiply. Well, this goes into this 3 times. 0 cancels 0. 12 into this is 2. 12 into this is 3. 3 cancels 3. So the circumference C would be equal to 2 times 22 times 22 times Ooh, what a mistake. Lord, prepare me to be a sanctuary. And the students them did not say, sir, you made a mistake. This is not the formula. All right. It's theta. L is theta times 2 pi r. Nobody said, sir, you made a mistake. Nobody. 240 over 360. Nobody. Times 2 times 22 over 7 times 21. 0, 0, 12, 2, 12, 3, 7 into this goes 3, the 3 here cancel the 3 here. So it's 2 times 2 times 22. This is 88 meters. So the L, which is the length of the arc, becomes the circumference of the cone, the circumference of the base of the cone, which is 88 meters. All right, so started off making an error, but I recovered. No thanks to anybody but myself and God. Next, we're asked to calculate the radius of the base of the cone. Well, it's easy. The circumference C, which is equal to 2 pi r, is equal to 88. Please note, the radius I'm calculating is different from the 21, which is the radius here. All right, that 21 became the slant length. So it's different from this radius. So this is 2 times 22 over 7 times r, I don't know, is equal to 88. So 44r over 7 is equal to 88 over 1, cross multiply, 44r would be equal to 7 times 88. Divide both sides by 44. And we get r is equal to 14 centimeters. So this r is 14. This is 21. All right. We could always use that to find the height of the cone. So the next thing we need to do is to find the height of the cone. Obviously, to find the height of the cone, I can now use Pythagoras Theorem. So c squared is equal to h squared, is equal to a squared plus b squared. So this is the hypotenuse, which is 21, is equal to the height square, which we don't know, plus the radius square, which is 14 squared. So 21 squared is 441, is equal to h squared plus 14 squared, which is 196. So h squared is equal to 441 minus 196. So this is 245. H, the height of the cone, is the square root of 245. H is this is 15.7 centimeters. The height of the cone is 15.7 centimeters. Please note, the radius of the sector became the slant length of the cone. Also note that it is the radius here is for the sector and the radius down here is for the cone. The radius up here dealing with the sector. The radius down here is dealing with the cone. All right, so now that we have the height, we can calculate the volume of the cone. Lastly, it's the absolute last thing for us to do. Now, the volume of the cone is equal to 1/3 AH. Did we calculate this A already? I don't think we did. So it is 1/3 pi, which is 22/7 times the radius, which is 14, times the height of the cone, which is 15.7. U into U goes 2. So multiply everything at the top and then divide it by 3. This is 22 times 2 times 15.7, and then divide by 3. And the volume of the cone would be 230.3, and this is centimeters cube. All right, that would be the volume of the cone.